All right, time to put on our detective hats. Today, we're going to crack a super common case in the AWS cloud, the mystery of the failed network connection. And we'll be using a really powerful, but let's be honest, often misunderstood tool, VPC Flow Logs, as our magnifying glass. So, let's get this investigation started.
And hey, if you've ever felt overwhelmed by this stuff, you are not alone. Even the pros get tripped up. The author of our source material said it perfectly. One thing I didn't expect was how complex the flow logs would be. They sent me into a bit of a downward spiral. Sound familiar? Don't you worry. By the end of this, you're going to see those logs not as a problem, but as your #1 clue-finding tool.
Okay, first things first. Every good detective story needs a crime scene. So let's go ahead and set the stage for our network investigation.
So what's our crime scene? Well, it's an Amazon VPC, which stands for Virtual Private Cloud. The easiest way to think about it is like your own private, secure room inside this giant, massive AWS data center. It's the place you can keep all your apps and your data completely locked down, far away from the prying eyes of the open internet. And our mission, if we choose to accept it, is actually pretty simple on the surface. We just need to create a secure, private connection between two of these digital rooms. We need them to be able to talk to each other, directly and safely. So here's what our network detective has already put in place. We've got two VPCs, each with its own unique address range, so they don't step on each other's toes. Inside each one, there's an EC2 instance. That's just a virtual server. Now the security groups, think of them as the digital bouncers for our rooms. They're set up to allow pins, which are just simple little "are you there" network messages. And the most important part, VPC flow logs are turned on. These are our security cameras, recording every single piece of traffic that tries to come in or go out.
The stage is set, the cameras are rolling, but then, the moment our detective runs their first test, they realize something is very, very wrong. So here's the big question, right? With everything we've set up, should our two EC2 instances be able to talk to each other using their private IP addresses? I mean, it seems like they should. What do you think?
And the answer is a big, resounding nope. The ping is sent out into the void and nothing. No reply ever comes back. Our connection has failed. The mystery officially begins. Okay, now this slide gives us our first huge clue. When our detective tries to ping the public IP address of the other machine, it works. But when they use the private IP, it fails. So what does that tell us? It tells us the instances themselves are working just fine. The problem isn't with the rooms, it's with the hallway between them. Or, more accurately, the lack of a hallway. So, just like any good detective, it's time to stop guessing and start examining the evidence. Let's follow these digital breadcrumbs and see where they lead. Our first stop is the route table. You can think of a route table as the GPS for your network traffic. It has all the rules that tell data packets exactly where to go. And if a destination isn't programmed into this GPS, well, that packet is just going to get lost. And this is where we find our smoking gun. The author says it right here. Looking at VPC1's route table, I identified that the ping test failed because it doesn't have a direct link set up to the other instance. It's really that simple. VPC1 has absolutely no idea how to get to VPC2. It's like trying to drive to a street that isn't even on your map. So we've identified our culprit. It's a missing route. Now it's time to bring in the tool that's going to crack this case wide open. And that tool is a VPC Peering connection. This is an awesome AWS feature that acts like a secure, private hallway built directly between our two VPC rooms. The traffic doesn't have to go out to the scary public internet. It just zips right through this private tunnel, almost like the two VPCs are part of the very same network. So how do we actually do this? It's a pretty clear 3-step process. First, you create the peering connection itself. Second, and this is so important, people forget this all the time, you have to update the route tables in both VPCs. It's not enough for just one to know the way, they both need the directions. And finally, you add that new route in each table, telling traffic destined for the other VPC to go through your new peering connection. And with that, boom, success. The ping is sent, and a reply comes back almost instantly. Our two instances can now talk to each other privately and securely. Case closed. And you know, the big takeaway here is so crucial. Just because your stuff is in the cloud doesn't mean it can automatically talk to each other. You have to be the architect. You have to explicitly build and define those connections. So the case is closed, but a great detective always reviews the case file to make sure they understand exactly what happened. So let's go back to our security footage, the flow logs, and see the full story they were trying to tell us all along. Before our fix, this log probably looked like a bunch of gibberish, but now we can totally decode it. Looking at a rejected log entry, we can see the whole story. We see the source IP, we see the destination it was trying to reach. And that reject status, that's our confirmation. The traffic was blocked because, you guessed it, there was no route. That final OK just means the log itself was recorded successfully, not that the traffic was.
So you see, the flow logs really do give us the full story. They are the definitive record of every single connection attempt. They tell you what was sent, where it was trying to go, and most importantly, whether it was accepted or rejected. For a network detective, these things are an absolute goldmine. But okay, what if you have thousands or even millions of these log entries? You can't sift through them by hand. That's impossible. That's where a tool like CloudWatch Logs Insights comes into play. Think of it as a super-powered search engine made specifically for all of your log data. For example, when something goes wrong, the first thing a detective wants to know is, what just happened? This simple little query does exactly that. It's basically saying, hey, show me the timestamp and the message for the 10 most recent things that happened. With just one line, you can cut through all that noise and get straight to the freshest clues.
And that brings us to the end of our case. We started with a failed connection and a log file that looked really confusing. But by understanding the route table, putting in a VPC peering connection, and finally learning how to decode the logs, we solved the mystery. So, the final question. That's for you. Now that you can read the logs, what other network mysteries do you think you could solve?